While normal user authentication may not be able to differentiate between identical twins who share the same login credentials, role-based authentication can be used to differentiate between users based on their roles and access level within an organization. This ensures each user is able to access data and features that are appropriate for their role, even if they share the same login credentials. By keeping these best practices in mind and leveraging the tools available to you, you can ensure that your user authentication systems are secure, reliable, and effective. But with even all these tools at your disposal, it's important to keep in mind the fundamentals of user authentication. Passwords should be hashed to prevent them from being easily compromised. Let's give an example. Let's say you have a web application that uses user authentication to access certain features and data. One day, two identical twins, Alex and Max, try to access the application using the same login credentials. The application uses both role-based authentication and normal user authentication to differentiate between users. Role-based authentication is a type of user authentication that grants access to certain features or data based on the user's role or position within an organization. For example, an employee may have access to certain data that a customer does not. In our scenario, let's say Alex and Max work for different departments within the same organization, and they have different roles and access levels within the application. Normal user authentication is a type of user authentication that verifies the identity of individual users based on their login credentials, such as a username and password. In our scenario, Alex and Max share the same login credentials, which means that the normal user authentication will not be able to differentiate between them. However, the application uses role-based authentication, which means that Alex and Max's different roles and access levels within the organization would be used to differentiate between them. For example, Alex may have certain data or features that Max does not, based on their different roles within the organization. This would ensure that each twin is only able to access the data and features that are appropriate for their role and responsibilities are displayed. We'll be focusing on few use cases, which include online banking, social media, email, and corporate networks. In online banking, when you log into your bank's website or mobile app to check your account balance, transfer money, or pay bills, you are required to either enter your username or password. This is an example of user authentication, which ensures that only you can access your account and perform transactions. That also happens with our social media accounts. When you log in into your social media like Twitter, Instagram, LinkedIn, or Facebook, you are required to provide login credentials. That is also another example. When it comes to email, if you also log into your email, whether it's your cPanel email or your Gmail or Yahoo Mail, you are required to enter your credentials to access your inbox, read, and send emails. This is also another example of user authentication. When it comes to corporate networks, which is enterprise software, when an employee logs into their company network, they are required to enter username, and also a role-based authentication might be implemented to abstract certain data layers from different users. There are generally three main authentication strategy classes used in user authentication. They are, number one is the knowledge test, which is also called something you know. This authentication strategy involves verifying user identity. The user is required to enter the information during the login process. If information matches what's stored in the system, the user is granted access. The next one is something you have, or ownership test, deals with physical tokens or smart cards. Basically, if you don't have your physical token or your smart card, you're going to face issue logging into the system. While the third one is something you are, or biological test. The authentication strategy of this biological test involves verifying the user identity through something that they are, such as biometric fingerprints, eye scan, or facial recognition. In summary, the three main authentication strategy classes are used in user authentication. Each strategy has its own strengths, weaknesses, and many systems use a combination of this strategy for added security, such as two-factor authentication. Just like any system, This also has its own pitfall. Here are the basic challenges for authentication strategy classes. For the knowledge test, passwords can easily be guessed or cracked, especially if they are weak or commonly used. Also, users may forget their passwords, leading to frustration and loss of access. On the second strategy class, which is the ownership test, major of the issues include physical token or smart cards can be lost, stolen, or damaged. Mobile devices can be lost or stolen, and there are also additional costs associated with providing users with physical tokens and smart card. And the third strategy class, which is the biological test, has its own pitfalls as well. Biometric data can be difficult to store and collect. Biometric data can also be replicated, and also biometric data may change over time, such as age or injury, leading to potential false rejection or false acceptances. To ensure maximum security, you can combine two authentication strategies, such as two-factor authentication and biological-based authentication. Two-factor authentication is a type of user authentication that requires to provide two forms of authentication to gain access. Basically, it involves something the user knows, such as password or PIN, or something that the user has, maybe a physical token or a fork. When it comes to biological-based authentication, on the other hand, it involves verifying users' identity through biometric data such as fingerprint, eye scan, or facial recognition. To implement both 2FA and biological-based authentication, the user will require to provide their login credentials as well as the biometric data. For example, the user might enter their username and password and then be prompted to provide their fingerprint or facial recognition for verification.